Section 2.4 is going to discuss lots of different formulas, and the idea in this section is to solve the equation for a specified variable. So meaning you want to get a certain letter in a formula or equation by itself. So we'll start with problem number 38. Now some of these things are things that you might recognize, some aren't, but on 38, I can't say I recognize this one. You have the equation C equals 1/7 times capital R times T. And the goal is to solve for R, capital R. We want capital R by itself. And they'll tell you that in the problem. You're not supposed to guess that. Well, in order to solve for R, you want to get this variable by itself. You don't want anything else on that side of the equation. So you start looking at the things that you have here. R is being multiplied by 1/7 and multiplied by T. I'm going to get rid of those kind of one at a time. The first thing I'll do, and it's a suggestion I made earlier when we were discussing the homework, is I'm just going to get rid of the fractions. How can I get rid of the fraction for problem number 38? All right, what's the reciprocal of 1/7? 7. 7 is also the lowest common denominator. So we'll multiply both sides by 7. Thank you. On the left-hand side, I get 7c. How do things simplify on the right-hand side? The 7 and 7 cancel, so what's left? RT. Almost sounds like a character from a Star Wars movie. RT is left on the right-hand side. I want to get R by itself, though, capital R. Any suggestions? What could I do to get R by itself? Good, divide by T. You take a look at this. R is being multiplied by T. The opposite of that would be to divide by T. So I'll divide by T both sides of the equation, and I get 7c over T equals capital R. Hey. And that's the goal, is to get that specified variable by itself. No coefficients, no exponents, just completely by itself. What's different about this is that instead of getting x equal a number or a equals a number, you're going to get an expression, not a number. But the ideas are the same, so it's a good follow-up to our work in section 2.2 and 2.3, where we're solving equations. We're looking okay with that first one on 38. Let's try some more. Problem number 58. And again, we're going to go back to that theme of working with fractions. The reason I emphasize that is because there's going to be some problems on your exam that ask you to work with fractions or equations that have fractions. Now this is actually a formula that I do know. It's how to calculate the volume of a cone. So like an ice cream cone, if you wanted to figure out its volume, you'd use a formula like this. We don't have to worry about that. What we do have to worry about is getting H by itself. Now just like the last one, I want to start out by cleaning things up a little bit. So, Andrew, what would you suggest we start with? What would be a good first step? Get rid of the fraction. So how could I get rid of the fraction in this one? And what's that? Good. So I'll multiply by 3 on both sides. On the right-hand side, I wrote it as 3 over 1. Per your suggestion, that's the reciprocal. Because I want to encourage the cancellation here. The 3's cancel each other out. Cool. Dino, what's left? What equation pops out of this after I simplify things? So it's pi r squared h. All right. Almost done. I want to get rid of what? What two things? pi and the r squared term. So how could I get rid of pi and r squared from the right-hand side? What's telling you to divide rather than subtract? I mean, you're right. I'm just kind of asking. Yeah, division is the opposite of multiplication. All right. A lot of times people are tempted to say, oh, well, I want to subtract pi r squared from both sides. Subtract pi r squared. Well, guess what? These aren't like terms. If I subtracted pi r squared from both sides, I get 3v minus pi r squared equals pi r squared h minus pi r squared. It wouldn't get me anywhere. All right, they're not like terms. You cannot subtract them. You cannot subtract off that coefficient. The way to get rid of it is division. The opposite of multiplication is division. So on the right-hand side, I'm left with an h. On the left-hand side, 3v over pi r squared. All right. So like I said, a common theme with these first couple, start by getting rid of the fractions. It's just going to make your life a little bit friendlier, a little bit easier when you don't have fractions to work with in these problems. Okay. Your turn for one. Before I give you one, which will be problem number 54, is there any questions on the first two? Problem 54 looks like this. X equals A plus B over 2. And we're asked to solve for B on both sides. Or not on both sides, but it's asked to solve for B. So, this is another one that deals with some fractions. Let's see what you got. Okay, so I like that you guys have caught on to the idea of multiplying by the reciprocal. In this one, I guess the idea is not so much the reciprocal as the lowest common denominator. So if I multiply both sides by the lowest common denominator, that LCD is 2. Now for convenience, I'll write it as 2 over 1. It's really just 2. The nice thing is I can get rid of that 2 right away. And on the left-hand side, I'm just left with 2x equals a plus b. All right, so let's subtract what from both sides now? A. How come I'm subtracting and not dividing? Right. The opposite of adding a would be subtract a. So always go back to this idea of opposite operation. 2x minus a equals b. All right, let's put away the fractions for a little bit and work on some other ones. Are we okay with 54? Again, you know, the idea is to start by clearing out the fractions. If that's multiplying by the lowest common denominator or by the reciprocal, either one works. Reciprocal, why don't we want to multiply by the reciprocal here? If we did, that would make the left-hand side a real big mess, because the reciprocal here would be 2 over a plus b. So now I'd just be moving the b term to the other side, and even worse, it's in the denominator now. So yeah. Yeah, please, look under.
Writing it as 2x over a equals b, that's wrong.
Correct. Because in this last step, you're adding a to b. So to get rid of an addition, you're going to use subtraction. Or, yeah. All right. Yeah, yeah, but right here, I mean, if you wrote it over a, then you've divided. Right. Problem 48. No, let's see, 42. My bad. Y equals mx plus b. So this is actually an equation we're going to see later in this course. It deals with the equations of lines, graphs of lines. It's what's called slope-intercept form. Let me make that a little bit more clear. That's y equals mx plus b. They actually want us to solve for b in this one? Or is it h? Solve for x. Oh, okay. Yeah, that makes it a little bit more interesting. All right, so let's solve for x. Where do we start? Suggestions. Good, subtract b. So I get y minus b equals mx. Looking good. From there, what? Divide by m. Nice. So y minus b divided by m equals mx over m. X is being multiplied by m, so it's the opposite would be to divide by m. And we'll just leave it like this. There's really no simplification you can do here. There's no special cancellation or way to reformulate that. Let's just leave it like this. That looks pretty good. All right. I'll do one more, and then maybe I'll give you 2 to do yourself. But I think we're doing all right on this one. So let's try problem number 44 together. A equals P plus PRT. So this formula has to deal with principal and interest. And we're asked to solve for T in this particular case. Generally speaking, you're going to work in kind of your reverse order of operations, so that you're going to do your addition and subtraction before you do multiplication and division, with the exception that if there's fractions in it, maybe we'll get rid of those first. Since there's no fractions in this, I'm going to subtract p from both sides. A minus p equals PRT. Okay, let's look a little bit closer. Sabrina, I'm looking to solve for t. What can I do to both sides of the equation to finish solving for t? Good. Divide by PR. For those of you who are not in the running world, PRs, runners usually refer to it as your personal record or your personal best. So A minus P divided by PR. There. Nice. Ruben? Well, what's true is it's a multiplication. It's P times R times T. So they're all being multiplied together, and we can just divide out that term, or get that term, the T by itself by dividing by P and R as a product. So if you take a look at the right-hand side here, the P's cancel, and then the R's cancel. So you're left with just T. Does that help? All right. Let's do a couple for you. So problem 46. 3x plus 4y equals 20. And the goal here is to solve for y. And then problem number, let's do 66. Pretty similar. 5y minus x equals 25. Now I'll give you a heads up. In both of these problems, you'll end up with fractions as part of your answer. That's okay. There's nothing wrong with a fraction as part of your answer. Oh, thank you. In 66, you're going to solve for y again. All right, so let's finish these two off. First thing I'm going to do, trying to solve for y, the low-hanging fruit here is just to get rid of the 3x. I can move that over to the right-hand side. I'll get 4y equals 20 minus 3x. The last step, y is being multiplied by 4. The opposite of multiplying by 4 would be to divide by 4. So I'll divide both sides here by 4. So divide by 4, divide by 4. One expression that you could write for the final answer is this: 20 minus 3x over 4. And I gotta say, I was really impressed by a lot of you guys that I saw on the left-hand side of class. Some of you simplified it. Now, I'm fine with it like this. The big temptation for a lot of people is to say, ooh, you can cancel the 4 into the 20. Well, you can't. Not like it is just now. These terms are mathematically joined, right? I've talked about this before. They're married. If you break up that marriage, you're going to write homewrecker all over your test. Bad news. You don't want to be a homewrecker in this class. What you can do, what a lot of people are like, oh, God, I want to cancel that 4 into 20. You can divide both terms in the numerator by that term in the denominator. Now you're no longer canceling into that. And you end up with 5 minus 3x over 4. What would be wrong is just to cancel the 4 and the 20 and say 5 minus 3x. That 3x is also divided by the 4. So I'd accept either of two answers. The first one here, that's fine. Or the second one over here, that would be fine. Either one is fine. So you guys on the left-hand side, I didn't get over to the right-hand side, but the left-hand side, you guys did a real good job of that. Similar things going on in problem 66. I want to solve for y. I'll start by adding x to both sides. 5y equals x plus 25. How do I finish this one up? Divide by 5. So divide by 5 on both sides. I get y equals x plus 25 over 5. Can I simplify that all? Cancel the 5 into the 25? No. Same thing as the last one. You could write it as x over 5 plus 25 over 5. If you did that, I would like the simplification. So x over 5 plus 5. So once more, I'll give two possibilities for the answer. This one is fine, or this one is fine. All right, but don't leave it kind of in the middle, and don't cancel the 5 into the 25, and not also divide the 5 into the x. Those are looking pretty good. Yeah.
So, in the beginning, all the way in the beginning, what if we meet this y on the y side and we take off the 5, then take the 5 from the
Sure. You could do that. So
25,
that's another way to work this. If you start by dividing everything by 5, like this, you're going to get y minus x over 5 equals 5. And then just add this term to the other side, or to both sides. So x over 5, add to the left-hand side, and to the right-hand side. Now on the left-hand side, these things cancel each other out, right? Because you're adding a number to its opposite. But on the right-hand side, you get y equals x over 5 plus 5. And guess what? That's the same thing we got down here. So there's a lot of different ways to work these things. I try and recommend some easy ways to work it. You have to discover what's best for you, and I'll check your work. But in this case, you're getting the same thing, so I got no problem with that. Okay. Let's see. One, maybe two last problems. Let's take a look back at problem number 70. A little different here. X squared plus y squared plus z squared equals d squared. And we're asked to solve for y squared. So what's different about this one is that you're not actually asked to solve for a variable in particular, but the square of a variable. So a little different. We're going to do this in one step. Let's just get rid of this problem right away. We want to get y squared by itself. How come y squared isn't by itself? What else do we have going with it? You got an x squared and a z squared. How could you get rid of these things? Jacqueline, any suggestions there? It's a great question. You can't take the square root of these and get rid of the squares like that. Not on the left-hand side anyways. Maybe I'll demonstrate that in a minute. Tomer?
Can we move them to the other side?
By doing what?
Like subtract. By the negative of x and z and move it to the side of e.
All right, so let's subtract x squared and z squared from both sides. So I'll subtract x squared from the left-hand side. And when I do, that cancels out. When I subtract z squared from the left-hand side, that cancels out. What equation is left? Y squared, which is what we're asked for, equals, good, d squared minus x squared minus z squared. Are we done? Yeah, cool. One and done. One step. Gotta like that one. Last one, problem number 78. Going back to where we started, which is working with some expressions that have fractions. So if you're getting the idea that I want you to be able to work with fractions, then you're pretty observant. So d equals c minus s over n, and we're asked to solve for s. George, what do you think we should do to start this one? All right, how are we going to get rid of the n? Good. So we're going to multiply by the lowest common denominator on both sides. The lowest common denominator is just n. All right, thanks, George. So we're going to get some nice simplification. When we do that, on the right-hand side, the n cancels. What equation comes out of this one, Victoria? D times n equals c minus s. Good. All right, a couple more steps to finish solving this one. Timer?
Move the c to the other side.
All right, so I'll subtract c from both sides. dn minus c equals what? Negative s. Am I all done? Can I just call it quits here? No. Can't. I got to get rid of the negative. So how can I get rid of the negative? Divide by negative 1. So dn minus c equals negative s. Everything there is going to have to get divided by negative 1. Divide by negative 1, divide by negative 1. And even that c there. All those terms get divided by negative 1. What equation do I get? Plus c equals s. Good. Thank you. So that's just going to change the sign on both of those terms. You could also, at this point, have multiplied everything by negative 1. It would have the same effect. So are we okay with our solution for s here? Kind of a shortcut if you're comfortable with it. Notice what happens to the C when I move it to the other side. Started out here as positive C, ended up here like this. So effectively, what's the shortcut? When a term changes sides, what else changes? The sign. So if you started out here, said to yourself, you know what? If I move that S to the side, it's going to change signs, right? So if I move that S to the side, it becomes positive. And if you're comfortable with it, let me emphasize this, if you're comfortable with it, dn equals C minus S, you can play kind of a little switcheroo here. You say, well, I want a positive S. Let me move that to the other side. But when I have that positive, I need to get rid of this as well. So you're moving two terms at once. They both change signs. S equals C minus D times N. Yeah. If you're comfortable. If not, go with what works. For homework, try 21 through 27 and 33 through 79, just the odds. That's section 2.4, starting on page 138.